as you settle comfortably into the stillness of the evening. Allow your body to relax and your eyes to gently rest. In just a moment, the picture before you will softly fade to complete darkness, leaving only the quiet rhythm of your breath and the soothing, steady path of our narration. Tonight, we begin a calm and unhurried exploration into one of nature's most enchanting displays, the quiet luminescence that dances across the high, icy reaches of our atmosphere. Long before modern instruments recorded the invisible particles and magnetic currents shaping these celestial ribbons, human beings looked up into the midnight sky with silent wonder, noticing how the darkness would occasionally bloom with soft, ethereal color. It is a story written slowly across thousands of years, carried down by patient observers who stood beneath the cool night air, recording what they saw so that we might rest and listen today. Imagine traveling back thousands of years to the fertile, moonlit plains between the ancient rivers, where early skywatchers mapped the quiet movements of stars on tablets of damp clay. On the night of March 12, 567 BCE, a Babylonian astronomer recorded a quiet red glow sweeping across the northern sky onto clay tablet, VAT 4956, leaving behind the oldest precisely dated written record of an aurora. That far-off evening, as warm evening air brushed across the silent brick courtyards of Mesopotamia, an observer stood in quiet awe, carefully pressing cuneiform marks into soft earth to preserve the memory of a crimson veil moving gently above the horizon. It is deeply comforting to reflect that the very same quiet mystery we contemplate tonight was felt so long ago under that identical night sky, connecting us across the vast expanse of time through a shared moment of calm observation. As centuries drifted past like falling leaves in an autumn forest, natural thinkers across the globe continued to watch the sky, seeking words to describe the breathtaking glow that graced the northern horizons of Europe. On September 12, 1621, French astronomer Pierre Gassendi observed a gentle night glow over Aix-en-Provence and coined the name Aurora Borealis *, combining Aurora, the Roman goddess of dawn, with Boreas, the north wind. With those elegant words, he captured both the delicate, dawn-like brightness of the phenomenon and its true home in the far north. The name has endured through centuries, evoking the peaceful image of a soft morning light breaking prematurely in the deepest midnight hours, touched by the cool, quiet breath of a northern breeze. Now, as the screen darkens and the peaceful quiet of your room surrounds you, there is nothing left to do but drift along with the slow science of these heavenly lights. Over our time together, we will wander softly through the physics of solar winds, the invisible magnetic shield protecting our world, and the gentle atomic collisions that illuminate the polar skies. For now, simply let your body sink deeper into rest, feeling completely warm, safe, and still, as the timeless story of the Northern Lights cradles your thoughts and guides you into a deep, restful sleep. As night deepens and the world slows its pace, the sky becomes a peaceful canvas where soft, ancient mysteries unfold with quiet grace. Long before modern instruments mapped the subtle architecture of our atmosphere, observers gazed upward, watching faint curtains of pale emerald light drift across the dark expanse. For centuries, these silent displays felt distant and unreadable, hovering like glowing wisps of dreamwork over quiet rooftops and slumbering fields. Yet, beneath the stillness of a clear evening, subtle currents flow unseen, binding the earth to the immense quiet of space. The night air carries a gentle coolness that invites reflection, encouraging the mind to pause while considering how humanity slowly began to untangle the delicate threads of nature's hidden forces. In the calm silence of night, every flickering shimmer above speaks of invisible structures, guiding cosmic energy with an effortless, steady rhythm that eases the spirit into restful contemplation. On March 6, 1716, English astronomer Edmund Halley watched a rare auroral display over London and deduced that the glowing atmospheric rays were aligned with Earth's magnetic field, tracing invisible lines of force like iron filings around a magnet. Standing beneath the soft London sky, he observed how the brilliant arcs and shimmering streamers did not drift at random, but rather seemed to obey a grand, hidden geometry. The light, gentle and persistent, arched upward in smooth curves that echoed the mysterious pull of a compass needle. In that quiet moment, the sky became a living map of planetary forces. Just as fine metallic dust settles into elegant, concentric paths around a magnet, the luminous air high above revealed the shape of Earth's unseen magnetic embrace. It was a serene realization, joining the wonders of celestial observation with the quiet laws that anchor our world. These invisible geomagnetic lines form a vast, protective shield that wraps softly around our home in the cosmos, extending far beyond the reaches of human sight. Far above our heads, high in the tenuous layers of the upper atmosphere, tiny solar particles travel along these magnetic highways, guided effortlessly toward the polar skies. As they gently interact with gases in the air, their silent collisions release delicate glowing sparks of emerald, rose, and soft violet. There is no turbulence or sound to this high-altitude ballet, only a steady, rhythmic glow that shifts with the subtle breathing of the magnetosphere. Knowing these arches of light follow natural pathways offers a comforting sense of order. The cosmos is not chaotic, but intricately arranged, woven with invisible threads that hold every atom and star in harmonious alignment. Understanding this quiet celestial structure brings a profound sense of peace to the evening. Surrounding our planet is an unseen blanket, floating softly in the void, shielding the atmosphere while channeling energetic currents into breathtaking visual lullabies. Aurora is a continuous, gentle pulse of cosmic interaction, transforming hidden planetary forces into soothing waves of color. As you drift closer to sleep, Imagine those invisible lines of force curving gracefully around the Earth, cradling the world in an eternal, quiet architecture. The light sways slowly in the cool air, guiding your thoughts away from the day. Everything in nature moves with balance and quiet purpose, inviting your mind to rest in the calm, protective embrace of the nighttime sky. Long before modern instruments mapped the invisible forces surrounding our planet, early observers began to notice subtle, rhythmic connections between the Earth and the heavens. In 1741, in the quiet Swedish town of Uppsala, astronomer Anders Celsius and his colleague Olaf Hjorter spent cold, peaceful nights monitoring the northern sky. As quiet green auroral arcs drifted gently across the darkness, they noticed something remarkable inside their darkened observatory. A magnetic compass needle gently drifted by fractions of a degree, swaying in silent unison with the lights above. This tiny nudge of the needle offered the first tangible proof of an invisible bond connecting atmospheric lights with geomagnetic currents flowing through the Earth. Before this discovery, many believed the lights were merely reflected sunlight or glowing vapors. Celsius and Hjorter revealed that the shimmering green curtains in the night sky were deeply intertwined with the magnetic heartbeat of the planet itself, anchoring the celestial display to the Earth below. This realization transformed how naturalists understood the polar atmosphere, suggesting that the calm green glow was part of a vast, unseen electromagnetic web. When the sky brightened with silent color, the Earth's magnetic field resonated in turn, guiding energetic particles along hidden pathways through space. Yet for decades, these scientific observations were confined entirely to the northern hemisphere, where observers had watched the cold lights for generations. Beyond the equator lay vast, uncharted oceans, where nocturnal skies had long remained unrecorded in Western scientific literature. Naturalists wondered whether this gentle glow was unique to the Arctic realm, or if the magnetic forces of the planet created a similar spectacle near the southern pole. The answer lay waiting far across the sea, under entirely unfamiliar constellations. Decades later, maritime voyages began carrying observers deep into southern waters, where the night sky unfolded over peaceful, open horizons. On September 16, 1770, while navigating the quiet waters of the Indian Ocean aboard HMS Endeavour, Captain James Cook recorded a soft, pale illumination rising along the southern sky. His careful entry provided the first detailed Western account of the Aurora Australis, expanding humanity's understanding of the polar lights and hinting at their global reach. The soft illumination Cook observed hinted at a profound, mirror-like symmetry in nature, suggesting that polar lights are twin displays glowing simultaneously over both ends of our world. Today, we know that as solar wind streams past Earth's magnetic shield, it channels light into both polar regions, creating twin crowns that pulse in quiet planetary harmony, as these separate threads of discovery slowly wove together across the centuries. A grander and more harmonious picture of our planet emerged. The subtle movement of a compass needle in a Swedish study and the soft glow seen from a ship at sea were twin expressions of the same planetary rhythm. In the quiet, deep stillness of the polar night, magnetic field lines connect northern arcs to their southern counterparts in a balanced, continuous loop of invisible energy. To watch these lights from below, whether standing on frozen northern ground or gazing over quiet southern waters, is to witness forces that gently encircle and protect our world, inviting a peaceful, restful wonder as the night softly drifts by. As the 19th century moved quietly toward its close, the scientific pursuit of the night sky shifted from fleeting wonder into a patient cartography of light. For generations, astronomers and naturalists had recorded sightings of pale green veils from disparate corners of the globe. Yet, the true geometry of this celestial curtain remained shrouded in quiet mystery. In 1881, Swiss researcher Hermann Fritz published *Das Polarlicht, introducing contoured lines called isochasms that mapped centuries of sky sightings, and proved that the northern lights form a calm ring around Earth's geomagnetic pole rather than the geographic North Pole. These soft, concentric curves traced upon global charts revealed that the aurora was not an erratic scatter of high-altitude glow, but an organized crown resting gently above the high latitudes. Through his meticulous synthesis of historic observations, Fritz offered a sweeping view of how this luminous phenomenon favored specific belts across the planet. This discovery brought a soothing clarity to atmospheric science, inviting scholars to visualize the Earth wrapped in an invisible magnetic embrace, where early explorers had assumed the light gathered directly above the geographic axis of the world. Fritz's isochasms demonstrated how the oval halo shifted in harmony with the planet's magnetic core. To trace those mapped lines with a fingertip was to understand that every faint ribbon of emerald seen by sailors in the icy North Atlantic or villagers across northern valleys belonged to the same continuous planetary structure. The night sky was not fragmented or chaotic. It was breathing in steady, rhythmic unison around a tilted magnetic axis, gently guiding the eye toward an underlying order that linked distant horizons beneath a single, tranquil canopy. As maps brought structure to the theoretical understanding of the aurora, researchers sought to capture its living image upon a medium far more permanent than fleeting memory. In the winter of 1882, Danish researcher Sophus Tromholt set up long-exposure gelatin-coated glass plates on frozen snowbanks in Kautokeino, Norway, producing the earliest known photographs of a quiet auroral arc out in the profound stillness of the Arctic night, where the cold rested heavy and clean over the vast tundra. Tromholt worked with quiet precision. He rested his sensitive photographic equipment directly against the packed snow, allowing the glass plates to expose slowly under the clear, starlit sky. In the biting chill, the light left its faint, silvery signature upon the emulsion, recording the subtle contours of the sky without disturbing the deep quiet of the evening. Those pioneering glass negatives captured a silent landmark in human understanding, turning an elusive, floating phenomenon into a quiet keepsake of scientific patience. Where previous generations could only describe the aurora through quick pencil sketches or fading personal recollections, these delicate plates rendered the smooth arc of light with calm, unwavering fidelity. The soft glow of the arc, frozen onto glass amidst the remote wilderness of Cadocchino, showed the world that even the most transcendent atmospheric dances follow slow, gentle laws. As the night deepened over the snow-covered valleys, science and art rested side by side, leaving behind a peaceful visual record of a universe working softly and quietly in the dark. For generations, the luminous arcs that brushed across the polar night remained a quiet enigma, drifting far beyond human reach in the highest reaches of the atmosphere. Astronomers and observers watched from snowbound valleys, noting the precise moments when green veils shifted into subtle purple ribbons. Yet, the physical bridge connecting Earth to these ethereal curtains remained obscured by vast distance and night. In the late 19th century, a new way of understanding began to unfold within the quiet realm of laboratory physics. Rather than waiting for clear, dark skies along the frigid Arctic fringes, researchers sought to capture the governing principles of cosmic light within controlled, peaceful spaces. The goal was not to replicate the aurora's full, overwhelming scale, but to observe its fundamental mechanics in miniature, allowing the subtle harmony between magnetic forces and unseen streams of particles to speak clearly in the stillness of a darkened room. Within the quiet confines of his workspace in Norway, one scientist sought to recreate the delicate interactions that whisper across Earth's upper atmosphere. In 1896, Norwegian physicist Christian Birkeland recreated miniature auroral rings inside his Oslo laboratory by aiming electron beams at a magnetized brass globe called a terrella, suspended in a vacuum chamber. As the electric current hummed softly through the apparatus, cathode rays traveled through the thin, evacuated air toward the polished metallic sphere. Guided by the invisible magnetic field emanating from within the brass globe, the charged particles converged into glowing, halo-like rings near its miniature poles, perfectly mimicking the oval ribbons of light that embrace Earth's high latitudes. In that tranquil moment, illuminated by a pale purple radiance, the vast distance between laboratory science and the mysterious night sky vanished, revealing that the great polar auroras were driven by streams of energized particles guided down magnetic field lines toward the planet's magnetic poles. To gaze upon that small, glowing globe in the quiet darkness of the Oslo laboratory was to see the grand geometry of space rendered gentle, intimate, and understandable. It demonstrated with serene clarity that the northern lights were not mysterious distant fires or pale reflections from Arctic ice, but a continuous cosmic rhythm played out on a vast planetary scale. The same invisible forces that gently gathered electrons around the tiny brass terrella were simultaneously at work thousands of miles above the frozen tundra, drawing solar particles into soft, shimmering arcs around Earth's magnetic poles. Berkeland's delicate experiment brought a profound sense of stillness to the study of the skies, showing that even the most immense cosmic displays follow quiet, orderly laws. As night deepened outside the laboratory windows, the experiment left behind a lasting feeling of peaceful wonder. The glowing rings inside the glass chamber served as a tranquil bridge between human curiosity and the vast cosmos stretching out beyond our sight. High above the sleeping world, far beyond the reach of city lights, the real auroras continued their slow, silent dance across the Arctic sky, guided by the very same magnetic paths that had just burned so softly inside a sphere of glass. And in the quiet of the night, the Earth wrapped itself in these invisible lines of force, resting beneath a universe that moves with calm, continuous grace. In the quiet dark of the northern winter, where the cold air stills the surface of the fjord into a dark, mirror-like expanse, early science sought to understand how high these glowing banners of light truly hung above the Earth. For generations, observers had debated whether the aurora rested among the clouds, brushed the mountaintops, or drifted in the far silence of space. To capture the truth of their height, in 1910, Norwegian mathematician Carl Stormer positioned synchronized cameras 4.3 kilometers apart along the Altifjord to take thousands of baseline photographs, calculating the true height of night sky curtains using simple parallax geometry, standing under the starlight with telephone wires linking the distant camera stations across the sub-zero night. He and his assistants waited for the curtains to settle into quiet arcs, taking exposure after exposure as the stars drifted slowly overhead. Through these simultaneous images, the slight shift of the light against the background of fixed stars revealed that the brilliant ribbons were not low atmospheric vapors, but vast sheets of luminescent gas suspended high above the weather, residing in a realm where the atmosphere thins to near absolute stillness. The geometry of parallax was as elegant as it was soothing in its mathematical clarity, relying only on the spatial displacement between two quiet vantage points to transform an ethereal phenomenon into tangible distance. By mapping how a specific fold or shimmering edge in the light shifted relative to distant constellations. When viewed simultaneously from two separate points along the fjord, Stormer was able to triangulate the exact position of the curtain's crests and lower boundaries. Each photograph preserved a fleeting slice of time, converting the unpredictable dance of northern lights into quiet, measurable contours that proved the glow began far above the highest clouds and extended upward into the vacuum of space. This methodical mapping brought a serene order to the mysterious night, demonstrating that even the most elusive celestial displays move according to the gentle, unyielding laws of spatial geometry. As thousands of glass plates were developed in darkrooms illuminated only by safe red lamps, a comprehensive map of the upper atmosphere began to emerge, showing that the upper borders of these glowing drapes could reach several hundred kilometers high, while their lower edges descended with remarkable consistency toward a distinct boundary. It is at this lowest boundary, where the incoming solar particles plunge into denser layers of gas, that the colors of the aurora shift into their most subtle and intimate hues, while the upper reaches glow with the familiar pale green of atomic oxygen. The delicate magenta fringe visible along the bottom edge of low-hanging auroral curtains forms at altitudes near 90 kilometers, where dense molecular nitrogen gently radiates photons across 650 to 680 nanometers. At these lower, denser reaches, energetic electrons from the solar wind collide with diatomic nitrogen molecules, exciting them into state transitions that release these deep pink and violet tones before the energy can be dissipated through collisions. This soft border of magenta appears almost like an embroidered trim along the base of the curtain, marking the exact altitude where the atmosphere becomes dense enough to absorb the full momentum of the incoming particles. Watching this quiet boundary from the cold earth below, one witnesses the exact threshold where space meets our world, expressed as a silent, glowing ribbon of color resting peacefully in the dark. High above the quiet contours of the sleeping landscape, the atmosphere thins into a vast and silent realm where Earth softly whispers to the edge of space. In this transparent realm, far removed from the clamor of the ground below, the incoming stream of solar particles enters a delicate dance with the rarefied gases that cradle our world. Here, the subtle physics of atomic collisions transforms unseen kinetic energy into gentle, luminous waves that drift across the darkness. The most familiar signature of this cosmic encounter is a tranquil green veil that hangs suspended in the crisp polar night. The standard emerald glow of the aurora occurs at altitudes around 100 to 150 kilometers, where excited oxygen atoms slowly release a single photon of light at a wavelength of 557.7 nanometers after a relaxed 3/4 second delay. This brief yet unhurried pause before emission allows the green light to bloom smoothly across the sky, as if the upper atmosphere itself were taking a deep, calm breath before exhaling soft radiance into the void. Because the air at these heights is still dense enough to sustain frequent collisions, yet sufficiently sparse for excited states to endure, the emerald ribbons linger in serene equilibrium, gracefully painting the night in restful, familiar tones. Beyond the domain of the emerald curtains, the atmosphere ascends into even higher strata, where the night sky interacts with the very first hints of solar illumination. Even while the landscape below remains wrapped in deep shadow, the topmost fringes of our atmosphere can reach beyond Earth's dark cone to meet the faint twilight of distant sunbeams. In this remote expanse, different elements respond to the quiet touch of incoming energy, giving rise to subtle colorations that often escape casual observation. When high-altitude molecular nitrogen ions catch early sunlight high above Earth's shadow, they scatter photons at a wavelength of 391.4 nanometers, weaving a faint violet blue haze higher than 200 kilometers up. This delicate sapphire tint forms a high-altitude border, resting softly above the green glow below like a quiet twilight crest on an invisible ocean of air. The phenomenon of sunlit aurora demonstrates how layers of light can stack seamlessly across vast vertical distances, each distinct hue whispering of its own unique altitude and elemental chemistry. Together, these celestial layers create a harmonious portrait of our planet's invisible shield, where distance, sunlight, and atomic timing gently weave together. As you rest beneath the night sky, imagine these immense currents of color floating miles overhead with complete quietude, unfurling without a sound across thousands of miles of cold space. The slow, methodical release of light by excited oxygen and sunlight-scattered nitrogen ionizes the darkness into a comforting tapestry of emerald and violet blue. Every photon carries a tiny fragment of cosmic history, traveling downstream through the stillness to rest gently upon the eyes of those who look up in quiet wonder. In this serene interplay of geometry and physics, the night offers a timeless reassurance of balance, reminding us that even in the vast cold of space, light finds a way to softly glow and guide our thoughts toward restful sleep. As we ascend far beyond the familiar realm where night clouds drift, the atmosphere softens into a vast, whispering emptiness. Here, far above the standard green veils that sway closer to the earth, the sky moves to a much slower cadence. The air at these tremendous heights is so diffuse that individual atoms float in serene isolation, far removed from the dense thermal dance and churning turbulence of the lower winds. In this tranquil stillness, the northern lights transition from the vivid emerald glows below to a subtle, ethereal red soft as a faint memory of twilight lingering long after sunset. Looking up into this quiet expanse, one senses the profound stillness of space stretching outward without end, holding its breath beneath the timeless stars. High in these rarefied layers, the physics of light becomes an exercise in patient waiting. Faint crimson auroras form at high altitudes above 250 kilometers through a rare atomic transition where oxygen atoms gently radiate light at 630 nanometers. A process so slow it requires nearly 2 full minutes of undisturbed space. Down lower in the atmosphere, where particles are crowded together, energized oxygen atoms quickly bump into their neighbors in mere fractions of a second, relinquishing their extra energy through silent collisions before any red light can ever be born. But up here, bathed in the tranquil silence of the extreme upper atmosphere, an oxygen atom can hold its quiet excitation without disruption, lingering in peace until it finally releases a single, delicate photon of soft crimson light. This long, patient interval allows the red aurora to bloom not as a sudden spark, but as a slow, diffuse cloud that seems to hover outside of ordinary human time. Because the atomic transition takes nearly 2 full minutes to complete, any brief flutter or fluctuation in the incoming solar wind is smoothed away into a seamless, glowing haze. The crimson veil does not shimmer or ripple with the swift agility of green curtains. Instead, it rests high against the velvet darkness, a calm and steady presence spanning hundreds of miles across the night sky. To watch this high-altitude veil is to observe a cosmic clock ticking with unfathomable gentleness, measuring time not in seconds, but in the peaceful intervals between rare atomic encounters. In the deep quiet of the Arctic night, this high-altitude crimson carries an ancient, restful quality. It cradles the sky in a muted embrace, floating gently above the earth like a calm aura resting upon the edge of space. The light requires no haste, no effort, and no noise. It simply waits for the stillness of the upper air to allow its expression. As the night moves forward, the gentle red wash slowly brightens and fades with the rhythm of a deep, tranquil breath, inviting the observer to let go of the day's hurried thoughts and rest in the quiet beauty of the universe. As this soft crimson light lingers above the sleeping world, it reminds us that even in the vast reaches of space, nature proceeds with unhurried grace, leaving the earth safe, silent, and still under the endless sky. As midnight settles over the frozen north, the night sky displays a subtle intricacy that rewards those who watch with patient, unhurried eyes. Across the luminous emerald sheets of light, small and peaceful anomalies gently emerge. Sometimes, instead of bright emissions, narrow channels known as black auroras appear when localized downward electric fields clear electrons from small ionospheric regions, carving calm, dark lanes of shadow through the surrounding green light. These slender antiauroras do not break the stillness of the night. Rather, they accentuate the delicate structure of the upper atmosphere, serving as quiet reminders of unseen electrical tides flowing high above the earth. Like rivers of ink floating through a sea of glow, these dark features drift effortlessly, showing how subtle variations in electric potential can create negative space in the sky. To observe them is to appreciate how silence and shadow contribute to the overall tapestry of atmospheric physics, where even the absence of light holds profound scientific meaning. Beyond the familiar green curtains and shadow lanes, the vast night canopy occasionally reveals entirely distinct forms of luminosity that linger softly against the backdrop of stars. In 2016, citizen scientists with the Alberta Aurora Chasers helped identify Steve, a slender mauve ribbon flowing across the night sky, caused by a 25-kilometer wide stream of hot plasma moving westward at 6 kilometers per second. Unlike traditional auroral arcs created by direct particle precipitation along Earth's magnetic field lines, this serene, purplish glow represents a distinct thermal phenomenon born from intense subauroral ion drift. Patient skywatchers, armed with cameras and a quiet passion for the night, brought this gentle ribbon to the attention of atmospheric scientists, bridging the gap between everyday amateur observation and formal space physics research. The discovery reminds us that the celestial sphere still holds gentle mysteries, waiting to be noticed by those who simply pause to look up into the tranquil darkness. As it glides overhead, STEVE moves with a calm elegance, a warm river of light flowing steadily through the freezing upper air, inviting quiet contemplation from all who gaze upon its quiet track. These subtle phenomena, both the quiet lanes of shadow carved within the green light and the warm, purplish rivers flowing independently across the stars, illustrate how complex and peaceful our planet's high-altitude environment remains. As the solar wind continues its eternal interaction with the geomagnetic field, energy flows across the upper boundaries of our atmosphere in ways that are both immensely vast and exquisitely detailed. Resting beneath this quiet light show, an observer can feel the slow, steady rhythm of the Earth aligning with the cosmos. There is no rush in these atmospheric movements, only a continuous, restful dance of charged particles and thermal currents. As the night deepens further and the cold air settles softly over the sleeping landscape, the luminous patterns continue to drift effortlessly overhead. Each faint trail and dark channel offers a gentle reminder of the quiet, orderly physical laws guiding our world through space. In the stillness of the polar night, the mind rests easily alongside the steady, silent science of the sky. As night settles gently over the quiet Arctic landscape, the dark atmosphere above becomes a vast and peaceful canvas for subtle physical phenomena that exist far beyond the threshold of human vision. For centuries, patient watchers of the northern sky looked up at the shimmering curtains of emerald and violet, marveling at the visible beauty without fully realizing that the aurora holds deeper, quieter stories written in wavelengths undetectable to the naked eye. Beneath the serene stillness of the polar darkness, invisible streams of energy and gentle cascades of charged particles drift downward, guided with effortless precision along the graceful, curved lines of Earth's magnetic field. This soft, continuous flow forms an enduring bridge between the distant sun and our tranquil home planet, carrying subtle scientific clues about the vast cosmic currents that quietly shape the highest reaches of our atmosphere. Long before space-based sensors could measure these delicate atmospheric exchanges from high above the clouds, researchers on Earth devised patient, ground-based methods to listen to the upper atmosphere's quietest secrets. In 1939, at the Tromsø Observatory in Norway, physicist Lars Vegard detected Doppler-shifted hydrogen lines in the night sky, discovering the faint proton aurora created when solar hydrogen ions drift gently into the upper atmosphere. This groundbreaking, delicate observation revealed that the northern lights were not solely powered by nimble electrons cascading through the sky, but also by a softer, heavier rain of protons arriving directly from the solar wind. As these solar hydrogen ions gradually slow down upon colliding with atmospheric gas molecules, they share their momentum and emit a faint, diffuse glow, adding a subtle whisper of cosmic warmth and light to the tranquil Arctic night. Decades later, as scientific instruments were carried high into orbit beyond the dense filter of our air, researchers discovered yet another layer of invisible activity surrounding our peaceful world. In 1974, physicist Donald Gurnett used the IMP-8 satellite to discover that the northern lights emit natural radio waves between 100 and 500 kilohertz, a silent planetary broadcast absorbed harmlessly by the upper atmosphere. Known to space scientists as auroral kilometric radiation, these low-frequency radio emissions ripple outward into the deep void of space like a gentle, otherworldly symphony. Though human ears resting on Earth can never hear this planetary broadcast directly, sensitive electronic receivers orbiting far above the clouds register the steady, rhythmic pulse of our atmosphere singing softly into the surrounding dark. To rest beneath the northern lights is to rest comfortably within the reach of these quiet planetary rhythms. The air around us on the snow-covered ground remains completely still, silent, and peaceful, even as the high sky above hums with invisible radio waves and a gentle rain of solar protons. The protective atmosphere wrapping snugly around our world ensures that these powerful celestial processes remain a soothing, distant backdrop, harmlessly absorbed high above before they ever touch the frozen ground. In the deep, restorative calm of the polar night, we can simply breathe slowly, drifting off into sleep with the quiet reassurance that our planet is held safely within a soft, enduring cradle of light and cosmic harmony. Across the quiet, winter expanses of Lapland, where snow-laden pines stand like silent sentinels under a vast indigo sky, the night carries a stillness so profound that even the softest breath seems to linger in the crisp air. For generations, indigenous observers, Arctic travelers, and local villagers spoke in hushed tones of mysterious sounds that seemed to accompany the brilliant auroral displays above faint crackles, delicate rustlings, or the softest whispers echoing gently across the frozen landscape. For a long time, mainstream science viewed these accounts with gentle skepticism, attributing them to auditory illusions or psychological echoes created when the human mind attempts to attach sound to breathtaking visual movement in absolute silence. Yet, the steady accumulation of first-person stories kept the question alive, prompting dedicated researchers to deploy sensitive acoustic equipment into the freezing wilderness, listening attentively to the nocturnal air. In 2012, acoustic researcher Untu Lane recorded the subtle rustling sounds associated with the northern lights in Sodankylä, Finland, tracing them to static discharge within a temperature inversion layer just 70 meters above the ground. This landmark study provided concrete physical evidence for a phenomenon that had existed largely in folklore and personal memory, rather than originating high in the thermosphere where the visible aurora dances tens of kilometers overhead. These elusive sounds were shown to form remarkably close to the Earth's surface. The discovery shifted the scientific perspective, demonstrating that while the visual splendor of the aurora is born in the upper reaches of the atmosphere, its subtle acoustic companions are nurtured right within the shallow breathing layer of air just above the quiet, snow-dusted tree line. The key to this gentle phenomenon lies in the quiet physics of temperature inversion layers, which frequently form on cold, clear, windless nights in subarctic environments. As the sun sets and the Earth radiates its residual heat back into space, the ground surface cools rapidly, chilling the immediate layer of air resting above it. Meanwhile, a layer of slightly warmer air settles directly above this cold pocket, creating a stable thermal boundary that traps atmospheric particles and electricity close to the ground. During intense geomagnetic storms, solar particles charging the upper atmosphere induce an accumulation of electrical charges near the inversion boundary. When these opposing static charges build up sufficiently within the quiet, frozen air, they release tiny, harmless microdischarges, producing faint popping or rustling noises that travel softly through the darkness. Understanding these subtle acoustic mechanisms reveals a captivating sense of unity between the celestial and terrestrial realms. High above, solar electrons cascade down planetary magnetic field lines to illuminate the darkness in ribbons of radiant green, while down below, near the resting forest floor. The calm air quietly responds with its own delicate electric harmony. There is a deep comfort in recognizing how many peaceful, intricate processes unfold quietly around us in the dark, mostly unnoticed, until someone listens with patience and care. As the northern lights drift slowly across the celestial dome, the quiet rustle of the inversion layer gently dissolves into the overarching silence of the night, leaving the surrounding world enveloped in deep rest, gentle safety, and serene wonder. As the deepest hours of the polar night settle over the quiet snow, the vibrant ribbons of celestial light begin to settle into a gentler, more rhythmic cadence. High above the sleeping Earth, where the planet's magnetic field lines curve gracefully toward the polar regions, a quieter, almost meditative phenomenon takes place across the vastness of near space. Streams of electrons, suspended thousands of kilometers out in the geomagnetic realm, interact with gentle electromagnetic vibrations known as chorus waves. These natural radio waves ripple through space, softly coaxing the particles downward into our atmosphere in steady, rhythmic waves. Down below on Earth, the sky appears to breathe in slow, mesmerizing intervals. Pulsating auroras slowly brighten and dim in calm 5 to 15 second pulses as Whistler mode chorus waves thousands of kilometers out in space rhythmically guide streams of electrons into the polar atmosphere. There is no hurry in this quiet motion, only a peaceful, breathing rhythm that matches the deep stillness of the frozen landscape resting far below. This soft, predictable rhythm of the northern lights was brought into clear scientific understanding through years of patient observation and careful synthesis across the icy north. In 1964, geophysicist Sianikai Akasafu synthesized thousands of night sky photographs from Arctic stations to define the auroral substorm, mapping how quiet evening arcs slowly expand, ripple across the polar sky, and peacefully fade back into dark silence. Before his groundbreaking work, observers often viewed the aurora as an unpredictable array of chaotic bursts, difficult to track or understand. Akasafu revealed instead that even the most expansive auroral displays follow a graceful, natural cycle, a celestial narrative that begins in quiet evening stillness, reaches a gentle peak, and slowly resolves back into darkness. His detailed maps demonstrated that every period of activity contains its own natural conclusion, leading the night sky back to a state of soft, restful equilibrium. To trace this quiet return is to appreciate the profound order hidden within the physics of the upper atmosphere. Long after the bright curtains of light have relaxed, the sky retains the memory of their movement in soft, glowing embers of faint luminescence. The energetic particles that descended along magnetic field lines have shared their kinetic energy with atmospheric molecules, gently lifting them into excited states before allowing them to fall back to their peaceful ground state. This atomic relaxation mirrors the settling of the land itself. As the ambient temperature drops and the snowpack gleams under the pale starlight, nothing in this cosmic process is lost or wasted. Energy simply transitions from movement into quietude, leaving behind a tranquil atmosphere resting in perfect physical harmony. Standing under this vast, dark canopy, one can feel the comforting weight of that quiet return. The high-altitude interactions between solar wind particles and atmospheric gases, so intricate when expressed in scientific equations, ultimately dissolve into an inviting silence that rests over the snow-covered valleys. The faint green and violet glows gradually taper into barely perceptible whispers of light, merging seamlessly into the deep velvet of space. The Arctic air is crisp, cool, and still, filled only with the faint, soothing murmur of wind across snow. Every glowing arc and pulsing patch has completed its silent journey, leaving behind an atmosphere fully at rest. As the last subtle pulses vanish and the distant stars resume their solitary watch, the polar night wraps the world in a quiet, undisturbed peace, inviting a deep and dreamless sleep.